Hey, welcome. This is going to be a little demo on the lovely ARP 2600. First of a series, probably, if I have time. The first one is going to be a bit of a patch, a bit of a performance patch to give us a kick drum, snare drum, and a bass line. So I'm going to use the filter as a kick drum. This is the TTSH, the kind of DIY replica of the ARP 2600. So it has the Moog filter in, which sounds super sweet. Let's have a listen to that. I'm just going to turn the VCA up there. All of the faders are zeroed, as you can see at the moment. All down to the bottom, all to the left. Let's turn the VCA up. Let's send the filter into the VCA. And also going to use the ADSR to control that. You can start to hear it clicking. I've got the little switch here set for the envelopes to be triggered via the little internal clock, so it's switched downwards there. In an upright position, that's where you can trigger it from the keyboard. Down is for using the internal clock. The filter makes no sound unless you play things into it, but of course if we turn up the resonance, you can start to hear a bit of a pitch. Now we've got no decay or sustain or anything. Let's turn the decay time up. So the filter makes really nice sine wave. If we add a bit of ADSR to the pitch or the cut-off frequency, you can get a pretty good kick drum sound. I've got a SH101 plugged in. That's how I control this, because I don't have the old ARP keyboard. Problem is the keyboard is hardwired in to control frequency. So when I play up and down the keyboard, you can hear the pitch change. What you need is a little dummy plug. I've just got some of these adapters, and you can use those to break the circuits. So I'm going to plug it into the keyboard CV input there, and it just cuts the circuit and disconnects the keyboard to the filter. That's sounding pretty good. Maybe a bit more envelope. Great. What about snare? Well, we've got a noise generator, so we can use that for the snare. What we're also going to use is the electronic switch. This is pretty nice. It switches in time with the internal clock, and it has 3 connections. Interestingly, they're neither input or output, they're both. So we can either plug something into C, and every time it gets a clock it switches between A and B, so you could use those as outputs. Or you could plug 2 different things into those, and then what you get at C is an alternating between the 2. Today we're just going to use it C as an input and B as an output. So I'm going to come from the noise generator. We're going to start patching now, plug it into C, and then I'm going to come out of B into the ring mod input of the VCA, because I'm not really using that at the moment. So plug that in there, and let's have a listen. Great, so now we've got a kick and a snare. You can hear it distorts a bit. The 2600, generally it seems like unity gain is kind of a bit like a mixer, halfway up, and if you push it further, you can hear it starts to distort. We can use that as a creative effect, but it's perhaps a bit too much on that, so I'm going to bring it down a little bit. It's a bit more snappier now. Great. So let's bring up a bassline. Here we need some more patch leads. I'm going to use Oscillator 2 because it's got the most amount of different waveforms available. We've got sine wave, triangle, sawtooth and pulse. Let's bring a little bit of that in here. Now of course we can't run it into the filter because the filter is kind of being used as an oscillator at the moment, so we can't really run anything into it. We're not going to hear it. So let's bypass the filter and run it straight in. I'm going to run it straight into the mixer here because I want my bass line to be separate from the drums. I've got a spare input here. VCF is normal to that one. So I'm going to come out of, let's just come out of the sine wave first and plug in here. And bring the oscillator up. Bit boring because it's always on. That's not much control. How can we turn it on and off? Trouble is we're already using VCA, we're already using our envelope, but what we could do is use the ring modulator. This is quite a useful thing. You can either get those like Dalek sounds when you use fast audio rate ring modulation, but what we can use, let's get a longer patch lead, is the clock output. Go from the clock output to one of the inputs of the ring mod. The other input is already normal to VCO2. That's pretty good. We don't need a patch lead. Let's come out of there, find another patch, nice long patch lead. So out of the ring modulator, I'm going to come into this spare input. VCO2 we can't hear until we bring up that input. So now the internal clock, every time it's opening and closing, it's kind of acting like a gate, I guess. There's both audio and DC modes. Audio is if it's going plus and minus, bit like a waveform, going above and below the zero crossing point. DC is for going from zero and above. DC works much more like a gate. If we turn it on audio, you can hear it's kind of double triggering almost because it's going both positive and negative. Whichever way, it doesn't matter. You just have a listen and see which one you like the best. Not bad, but it's only a sine wave, so what other sounds can we get? VCO2 is normaled as a sine wave. If we want other waveforms, we're going to have to come out. So let's come out the sawtooth and in there. Kind of nice. What about DC? Yeah, it's okay. What about pulse wave? It's a bit bassier, isn't it? It's nicer. It'd be nice if we could filter it a little bit. We're already using the filter here as a kick drum, but one nice thing in the voltage processors here is the bottom one is a lag. Can be used for portamento. It can also be used as a low pass filter. So let's come out of the square wave into the lag processor, the bottom one. And then we come out of there, back into the ring mod. Sound changes slightly, and if we increase the lag time, notice it has a filtering effect. Cool, so we've got a bit of a filter. The ring mod also kind of has a bit of distortion. It's not super clean, especially when it's on DC mode, which is quite nice. I like it. That rhythm is a bit boring. Let's jazz that rhythm up a little bit. I'm going to use the sawtooth out. And I'm going to mix some voltages together using the top voltage processor. This one has two inputs that are on faders. These are just attenuators. There's two more inputs which don't have any attenuation. It's just purely being added together. So all four things get added together and they come out inverted from that output. There's three voltage processors. There's the top one, which is 4:1. The second one, which is 2:1. There's just one attenuator there and a pure non-attenuating adder. And then finally the last one is the lag process. Sawtooth out into there, and I come out of the clock. Patch leads out of the clock into the next one, and then we've still got a jack that's come out of there, so we've still got the square wave there. Let's add a bit of the triangle, speed up. This is in low frequency at the moment. And we can mix and blend them. So we start to get something that kind of bounces a little bit. I quite like that. Let's bring the pitch down. I haven't tuned this. So you can hear how each sounds pretty good. Be nice if that pulse width was moving a little bit. By default, and I don't know why, the pulse width is normal to the noise generator. It seems totally pointless to me, because all you get, I guess it gives a sort of distorted square wave. I don't know, I find it a bit difficult to use. The other really annoying thing about the 2600 is that the only oscillator that can generate a sine wave, which is what you may want to use to affect the pulse width, or the sawtooth, ones that just have both smooth up and down motions. They're both generated by the same oscillator, which has the pulse width modulation. Seems a bit crazy. So instead we'll use the sawtooth out there. It won't sound quite as good as a triangle or a sine, but let's plug it in. We're on low frequency mode here. Sounding good. Use a bit of the arpeggiator on the 101. Alright, that's enough. Thanks for watching. Hopefully get back with a new video soon. Cheers, bye.